What is the space-time continuum? In 1905, Albert Einstein stunned the scientific world with his theory of special relativity. This theory explained how the fundamental building blocks of matter interact. 1 year later, his former college math teacher, Hermann Minkowski, made another astounding announcement. He had a new scheme for thinking about space and time that emphasized their geometry. In a famous speech, Minkowski announced, "The views of space and time which I wish to lay before you have sprung from the soil of experimental physics, and therein lies their strength. They are radical. Henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union in the two will preserve an independent reality. In this new view, space and time must be combined into a new entity called space-time. This is because, mathematically, the space and time coordinates of any event must be mixed together in order to accurately describe what we see. Any space, whether it be your classroom or huge chunks of our galaxy, consists of 3 dimensions. This is because an object's location in 3-dimensional or 3D space can be determined by 3 things. 1, whether it is up or down. 2, whether it is left or right. And 3, whether it is near or far. Time, on the other hand, is 1-dimensional, 1D. Therefore, space, 3D, plus time, 1D, must be 4-dimensional, 4D. Space-time is known as a continuum because, as far as we know, there are no places in the universe where space is not 3D or where time is not going forward. In addition, both space and time can be subdivided infinitely. Therefore, unlike matter, whose smallest unit is the atom, we will never find the smallest unit of space or time. There can always be smaller units. Physicists now routinely consider our world and universe to be embedded in this 4D space-time continuum. All events, places, and actions can be described in terms of 1, their location in 3D space, and 2, the time at which they occur. These are difficult concepts, however, because as humans live in a 3D world, it is impossible for us to visualize in 4 dimensions. Therefore, space-time is often modeled as a 2D or 3D mesh. See figure at the left. In this case, the left is up here. And this artist's drawing helps us imagine how Earth creates gravity by curving the space-time continuum. It shows a spacecraft orbiting Earth to measure space-time. So that grid-like substance that kind of looks like a funnel underneath Earth, that is the representation of space-time that the book is referring to. After 1905, Einstein continued to work on the concept of relativity. In 1916, he published his theory of general relativity. This theory uses mathematics to explain how matter in the universe, including stars, planets, and moons, interacts. It explains that gravity is a force of attraction that affects space-time. It also shows that space-time must be curved. Wherever there is a chunk of matter, an apple, a person, a planet, or a star, space-time curves around it. This curving of space-time is what causes gravity. When the space-time continuum is curved, anything traveling through it must follow those curves. Anything caught within the space-time curves will be attracted to the object, like water flowing down a funnel. Einstein's equations showed that the more mass an object has, the more the object curves the space-time continuum around it. Small objects that are close to Earth, such as ourselves, are located near the center of Earth's space-time funnel, where the funnel is very steep. This is what keeps us connected to the ground instead of floating above it. Climbing out of the funnel takes a lot of force, which is why our space vessels need such huge rocket engines. Objects that are further away from Earth, such as the Moon, are located more toward the rim of Earth's space-time funnel. Here, the curves in space-time are much gentler. Therefore, the Moon orbits Earth rather than being pulled into Earth completely. Of course, the Moon creates its own curves in space-time, and thus has gravity that allows astronauts to come in contact with its surface, although not as strongly as to the much larger Earth. On an even larger scale, Earth and all other planets of the solar system orbit the Sun, because each is caught in the large curves in the space-time created by the massive star.